Hello, in this video we're going to solve the rational equation 4 over y minus 5 equaling 5 over 2y. What makes this a rational equation is the fact that we have two rational expressions in it. In particular, on the left-hand side, 4 over y is a rational expression, and on the right-hand side, 5 over 2y is a rational expression. One giveaway that you're working with a rational equation is that you're seeing some variables in the denominator. And it's actually those variables that we see in the denominator that help guide our approach to solving this equation. So with that said, noticing that the denominators in both those fractions involve variables, we want to start thinking about a way of canceling them out. So for instance, we want to figure out a way of canceling out the y here, but also the 2y. The necessary ingredient in order for us to do that is the LCM. Now the LCM of both those two fractions is 2y. Now check this out. I'm going to distribute 2y to what's on the left-hand side of the equal sign. So I'll put that in parentheses. So 4 over y minus 5. Now again, whatever we do to the left, we have to do to the right. So we're going to put the LCM on the right-hand side as well. I'm just going to jot down the original right-hand side and put it in parentheses to be consistent. So I mentioned distributing the LCM, and we'll go ahead and do that on the left. So 2y is going to get multiplied to 4 over y, but we'll also have to multiply 2y to the negative 5. So I'm going to write it out this way, 2y, and in parentheses, 4 over y. And when I multiply 2y to negative 5, that's going to turn into negative 10y. So here's the minus sign for the negative there, and then 10y. Now I'm going to leave the LCM in front of the fraction that's on the right, so that we can see the advantage of using the LCM to help us solve this equation. You'll want to notice that when you have the LCM in front of, say, like 4 over y, we're going to get one of the factors canceling out. There's some cross-canceling we can do. For example, and you're probably seeing it, the y's will cancel here. Now what's going to be left over is the product of 2 and 4. Alright, so eventually we'll write 8. Now on the right-hand side, we get some canceling too, or cross-canceling that is. Of course, the y's cancel, but the 2's do as well. So the LCM is designed to do exactly that. It's actually designed to clear out all these denominators, and what you're going to see in just a moment is that we wind up in linear equation territory. So let me just change pen colors. So I mentioned we're going to have 2 times 4 left over, so that's 8 minus 10y. And on the right hand side, we're going to have just y left over. I'm sorry, 5 left over. And here we are. We're back to linear equation territory. So all of those techniques that we were discussing with solving linear equations apply here. What I think I would go after next is subtracting 8 from both sides. So we'll do that. We'll subtract 8 from the left, 8 from the right. And what's going to be left over on the left-hand side is negative 10y. On the right-hand side, 5 minus 8 is negative 3. So one step away, we have to think about taking care of that negative 10 that's directly in front of y. So do recall that when the number is directly in front of it, it is multiplication. So again, like in the last examples, what we'll do is divide both sides to isolate the variable. So in this case, we're going to go ahead and divide both sides by negative 10. So on the left, what we'll have is the variable y isolated. And on the right-hand side, we have a negative 3 divided by a negative 10. So of course, a negative divided by a negative is a positive. So for that reason, I'm going to write the final answer as y equals 3/10. And just like in the last examples, we'll go ahead and check this in a different video. But that's it for now. Thanks for watching.